Who are we? Over the course of its existence, humanity has sought answers to fundamental questions. Who are we? Where did we come from? And what is our destiny after death? Successive generations have attempted to answer these complex questions. Myths inherited from ancient civilizations have emerged, but the torch of research was carried by scientists and philosophers in order to reach logical answers that clarify the relationship between humans and the world around them. Research has continued for centuries, ultimately leading to the modern scientific understanding that we have today. An understanding that has been able to answer the questions that have puzzled humans throughout history. In the 1940s, two main models emerged to explain how it all began. The first was the steady-state model proposed by astronomer and British mathematician Fred Hoyle. It posits an infinite universe, endless, in which matter was not created all at once, but rather exists continuously. The second model, proposed by Ukrainian physicist George Gamow, is known as the Big Bang model. It suggests that the universe originated from a tiny, incredibly dense atom that suddenly exploded 14 billion years ago, for reasons unknown. This explosion caused the universe to expand, a process that continues to this day. Initially, Hoyle believed that scientific observation would support his steady-state theory over Gamow's, which he ridiculed by dubbing the Big Bang model. However, the latter theory has ultimately been proven by scientific experiments and has gained wide acceptance. The Big Bang theory suggests that the universe began as a single atom, and the enormous energy released during the explosion created the first atoms of the elements, such as hydrogen, which then combined to form helium. This process of nuclear fusion generated large amounts of energy and light, leading to the birth of the first stars, and the eventual emergence of light in the universe. In 1965, astronomers Arno Penzias and Robert Wilson captured the light and won the Nobel Prize in 1978 for their discovery. Despite the evidence in support of the Big Bang model, Hoyle did not believe in the theory he had cynically called the Big Bang, remained committed to his steady-state theory until his death in 2001. However, by this point, his theory lacked any credible evidence to support it. Besides proving the observations of Edwin Hubble, by monitoring galaxies and confirming their state of divergence from each other, the depiction of the remnants of cosmic radiation resulting from the explosion through the 1989 exploratory moon mission validated the discoveries of Arno Penzias and Robert Wilson. Wilson may have inadvertently revealed an important truth when he said, "Many cases when there is a fundamental change of paradigm in science, it takes a generation to accept it, and I think the world is now ready to accept the reality of the Big Bang." For centuries, generations have searched for an answer to the question, where did we come from? There are religious narratives in all civilizations, but we have proven today that we came from a great explosion. Indeed, the Big Bang theory presented the ideal model for the creation of the universe, which science later confirmed as the theory adopted to this day. But what's next? What happened during the time that separates today from that explosion? What occurred 14 billion years ago, that led to where we are now? Let's start again. In an infinitesimal time estimated to be 1/1000th of a billionth of a second, an insignificant atom expanded to the size of an entire galaxy. It was an enormous creation, difficult to imagine, as it contained the energy of the entire universe. 380,000 years after the explosion, the first hydrogen atoms formed, which became the infrastructure for everything that followed. With more pressure and heat, hydrogen atoms can synthesize into other elements. This is what happened inside the newborn universe, as the gravitational force started to compress clouds of gas and dust into heat energy. At 18 million degrees Fahrenheit, hydrogen atoms merged strongly to create a new element, helium. As a result of this atomic merger, huge amounts of energy were released into space in light and heat. And so, the first stars were born, which not just the source of light and heat, but also material factories. Under the extreme pressure and enormous heat of stars, atoms merge and new elements of matter form. Hydrogen turns into helium, helium into lithium, then carbon, oxygen, nitrogen, iron. Thus, the first 15 essential elements were born. But what about heavier elements? Copper, zinc, bronze, gold, uranium, and other elements that stars do not have enough heat to make, are formed when stars begin to explode. These explosions are called supernovas, and they generate enormous energy that is sufficient to combine heavier atoms into the rest of the substances we know with the periodic schedule of elements. Over the course of 8 billion years, star factories have been in their cycle of making heavier elements, exploding stars, and rebuilding, then re-exploding as they emerge heavier elements from each generation. One of these stars is the Sun, which emerged 4.6 billion years ago, and collected 99.9% of the gas and dust in the entire solar system to be generated. From this, the planets orbiting it formed, including the third planet, Earth, which was born 4.5 billion years ago as a mass of dissolved volcanic rocks in which elements mix. The Earth was spinning at a faster rate than we know today. It completed a rotation in only 6 hours. This rotation caused the light elements to head towards the surface, constituting a crust that has cooled and hardened over time. The heavier elements dived towards the center of the newborn planet, creating an iron-nickel pulp that made the magnetic field around Earth, which protects it from harmful radiation coming from the Sun. The genesis of life on Earth allowed it to create the gravitational force that grabbed everything. But a foreign object traveling at a speed of 40,000 kilometers per hour collided with the Earth. And although the planet absorbed the colliding object, the debris from the impact continued to orbit the Earth, eventually coalescing into the beautiful silver orb that has been orbiting the sky since that day, the Moon. This collision also had a significant effect on the Earth's axis, which in turn allowed for the existence of life by creating the 4 seasons as the Earth orbits around the Sun. The Moon itself played a critical role in the development of life on Earth, as its gravitational pull slowed down the planet's rotation to create longer days and nights. The Earth was initially very hot and devoid of water, but as it cooled, water vapor in its atmosphere condensed and fell as rain, eventually forming the seas and oceans we know today. Then, 3.8 billion years ago, beneath the surface of these bodies of water, the elements of hydrogen, oxygen, carbon, and nitrogen combined to form a unique DNA that sparked the beginning of life in the form of organisms that were, and still are, central to the game: bacteria. So, we can say that the first and oldest living organism on Earth is the bacteria, that feed on sunlight, and their byproducts are oxygen, which is one of the most important elements of life. Water in the seas and oceans carried iron atoms, which combined with the new planet. However, when bacteria began their activity, feeding on light and releasing oxygen, a fundamental shift occurred. Oxygen atoms in water merged with iron atoms to form rust, iron oxide, which solidified and sank to the depths to become a source of iron for humans in the future. When there were no more iron atoms in the water to combine with oxygen, this oxygen began to escape into the Earth's atmosphere. Over the next 2 billion years, life forms in the water grew more complex. The sky turned blue, and land masses started to emerge, forming one mass named Pangaea. The air's oxygen rate became 13%, leading to the Cambrian explosion age about 550 million years ago. The first marine organisms that evolved in a series of mutations, according to the theory of evolution, only took 50 million years to give rise to the first bony fish in the seas, which are our ancestors. Plants and trees had emerged on land, and 400 million years earlier the great creatures living in the seas made a historic leap, when these amphibians came out of the water, to make their first strides on land as their new habitat. However, they could not completely break their relationship with the sea because of their eggs. Amphibian eggs are gelatinous and will dry up on land. But some of these amphibians solved the problem by developing a new form of eggs, enveloping them with a hard crust to protect the liquids and moisture inside. This led to the development of amphibians into reptiles, completely breaking the bond between these creatures and the sea, and becoming able to wander offshore to colonize the hard earth. However, 250 million years ago, the largest volcanic activity occurred since the Earth's inception, and the atmosphere was filled with carbon dioxide. This led to the extinction of more than 70% of the species that originated in the Cambrian explosion, in an era called the Permian extinction. Extinctions have had a profound impact on changing the shape of life on Earth, allowing organisms to spill over into the continuum of evolution. Dinosaurs dominated the Earth for more than 160 million years, during which forests emerged. The day have settled on Earth for 24 hours, and the mass of one land, Pangaea, began to disconnect to form continents. Under the feet of the dinosaurs, mammals barely existed. 65 million years ago, a rock 6 miles wide hit the Earth and caused the extinction of every creature weighing more than 50 tons, ending the age of the dinosaurs and giving mammals the opportunity to emerge as strong on Earth. Not long after the extinction of the dinosaurs, the first real primates, monkeys, appeared. Some of them had to go down to the ground to look for new environments after the grass swept through the Earth's surface, leading to scarce food. With time, these primates learned to stand erect on their hind feet above the grass level to observe predators, thereby moving on 2 feet and freeing the hands that formed human history. Hominins first set foot on Earth over 2.5 million years ago, before they began to think and make tools from stones to create spear blades and other items, marking the beginning of the Stone Age. 100,000 years ago, humans evolved into their current form, distinct from monkeys, and discovered fire. They started making complex sounds to communicate, share information, increase their intelligence, and expand to different continents. Around 50,000 years ago, the Ice Age threatened the extinction of many species, but human intelligence and adaptability helped them survive and thrive, leading to scientific and technological advancements that eventually allowed humans to travel to the moon. If our history began more than 14 billion years ago, how old is man in the age of the universe? Imagine reducing the age of the universe from 14 billion years to only 14 years. Humans would be only 3 minutes old in comparison. So, what is the age of a single human being relative to the age of the universe? The answer is insignificant. We are mere blips in the grand scheme of things. What is the value of this life? What are our values? And how can we believe that there is a God who created us and created everything in this universe for us? What do you think of this story? Does it look like a science fiction story? Do you have a religious inheritance in mind? Such a dignified verse in which God Almighty says, "I did not make them witness to the creation of the heavens and the earth or to the creation of themselves, and I would not have taken the mosquitoes as assistants." These are scientifically proven and certified theories that the entire universe is a coincidence. That there is no God of humankind's creation. And that humans have evolved from bacteria to fish to monkeys, and then to full, rational, and intelligent beings. Is this persuasion even without any religious reasoning? Please do not rush your answer. Our journey has not yet begun, and the next one is weirder and more surprising. It is essential to remember that these are not stories, but rather scientific theories presented by the world's leading scientists who studied and believed them at different stages of our education. Remember this well, as we will need it on our amazing journey.